Lift off, vehicles clear the pad.
Mission launched just a few weeks ago, carried satellites for our mission partner Spaceflight, who we're excited to be teaming up with once again for tonight's launch. So right now we're just 15 minutes and 45 seconds away from our targeted launch, so let's listen into mission control as they conduct their final health checks on Electron systems.
Okay, and all stations, this is flight on mission cord. Stand by for final pole for launch. RCO.
RCOs go for launch.
LD.
LDs go for launch.
Executive.
Executives go for launch.
Flight RCO mission cord.
Go ahead.
Open MCC launch switch cover and confirm.
Confirmed open.
Toggle abort. Confirm on board and watchdog.
Confirmed go. Confirmed abort, confirmed go.
Copy. Keep MCC launch switch cover up. You're on.
So as you've heard, our operators and launch director have confirmed that Electron is go for launch. We're approaching T-minus 14 minutes before target liftoff, which gives us some time to talk about the spacecraft for this mission. On board Electron today, we have a BlackSky Global 4 Earth imaging satellite. It joins the BlackSky Global 3 satellite that we launched on our last mission on June 29th. Both of these satellites form part of BlackSky's constellation to deliver rapid revisit satellite imagery to monitor things like crop development, herd migration, and urban planning. Spaceflight has also manifested technology demonstrator satellites for the United States Air Force Space Command on this mission. These satellites aim to test new technologies, including propulsion, power, communications, and drag capabilities, and how they might be used on future spacecraft. The final spacecraft on this mission is a CubeSat, forming the cornerstone of a new maritime surveillance constellation for a company called UnseenLabs. Their aim is to deliver precise, reliable, and secure maritime data, enabling organizations to keep an eye on their own vessels, as well as to watch out for those that present risks. Due to our trajectory, there's a possibility of losing tonight's video feed, but rest assured, we'll keep you updated here if that happens. In addition to that, we won't have live video footage showing payload deployment due to the location of the kick stage in orbit. So we'll be ending the webcast shortly after confirmation of the kick stage separation, so keep an eye on our social media feeds for confirmation of payload deployment. So now it's time for a few updates on the Electron program. From day one, the Electron program has been all about using innovation and creativity to provide frequent and reliable access to space. Developing a 3D printed engine that could be printed in just 24 hours was one step, as was developing the world's only private orbital launch site. But we're taking our plans to a whole new level to make our launches even more frequent for small satellites. Recently, we unveiled plans to recover and refly Electron's first stage. Capturing and reusing a rocket stage is an enormous technical challenge, but one that we hope will enable us to launch faster and more frequently by limiting the need to build a new first stage every mission. The plan to reuse Electron's first stage will be implemented in two phases. The first phase will see us attempt to recover a full Electron first stage from the ocean, downrange of Launch Complex 1, and then ship it back to Rocket Lab's production complex for refurbishment. The second phase will see us attempt to capture Electron's first stage in midair by helicopter before the stage is delivered to the deck of a ship and then transported back to Launch Complex 1 for refurbishment and relaunch. So we've got a quick animation for you that shows the planned midair capture process. Today's mission will carry critical test instrumentation in Electron's first stage to inform our recovery attempts in the future. Now, we're using the first stage of a small launch vehicle as a complex challenge, as there's little mass margin to dedicate to the recovery systems. For a long time, we said we wouldn't pursue reusability for this very reason. But after conducting some research and testing, we've been able to develop the technology that could make recovery feasible for Electron. So it really is an exciting next step for all of us here at Rocket Lab, because with the introduction of our reusability plans, and with our second launch complex in Virginia under construction, our goal to launch once per week is becoming a reality. So speaking of Virginia, let's have a quick update on the construction of Rocket Lab's Launch Complex 2 at Wallops Island. Construction on the pad is nearing completion, with almost all the concrete having been poured. The strongback and the latch platform are due for delivery to the site in the coming weeks, so from now on the focus starts to shift from construction over to integration and testing. This is of course the second launch site that Rocket Lab has built, and it really is exciting to see it all coming together again. A big thanks goes out to the hard-working Rocket Lab team in Virginia, also to our army of local suppliers and contractors, and of course to the team at Virginia Space who are making Launch Complex 2 a reality, all in record time. In the coming months, we'll be gearing up for the first Electron launch from this site. We can't wait to see Electron launch from U.S. soil. So we'll have more to share about that first mission, including the timing and the customer later this year. With all these exciting opportunities that I've mentioned, we're looking to bring even more people onto our Rocket Lab teams in Mahia, Auckland, California, and in Virginia. We've got roles in almost all of our departments, from hands-on roles, building and testing our rockets, and engineering and manufacturing, right through to our corporate functions like finance, HR, business support, and logistics. You could be at the very start of your career or a seasoned professional looking for a change. If you're looking for a great opportunity with a leader in the small satellite launch industry, please get in touch with us. You can check out the roles available at our website, rocketlabusa.com.
Stage 1, same to you. Please confirm Stage 1 engines are ready.
Confirmed. Avionics RCO mission cord.
RCO avionics.
Disable lock on FTS power.
FTS shore power lock disabled.
And switch FTS ground power off and confirm.
FTS ground power disabled. FTS is on internal power.
Copy that. FSO RCO mission cord.
Go for FSO.
FTS is now on internal power. Checkdown should be up here on.
Copy.
Enable failsafe and confirm.
Failsafe enabled.
And FTS, confirm FTS is green, enabled for flight.
FTS is green and enabled for flight.
So you may be wondering why we call this mission Look Ma No Hands. Well, before liftoff, Electron is secured to the launch pad by the strongback and its top clamp. It's that tall structure that you can see here standing behind Electron. At approximately 6 minutes before liftoff, the top clamp opens up and the strongback retracts away from Electron to clear away for launch. Once Electron is free from the strongback's grasp, it's Look Ma No Hands for Electron.
GC, disable all HVAC and confirm.
Stand by. All HVAC is disabled.
Copy that. Retract fairing umbilical and proceed with clamp open.
Stand by. Fairing umbilical is retracted. Top clamp is opened.
Copy that. And GC, go ahead and retract strongback for flight.
Stand by. Strong back has retracted.
Copy that. Proceeding with arming. Hold on.
So if you may be worrying about the white clouds that you see coming off the
Stand by.
rocket and some of the ground support equipment, they're actually clouds of really cold oxygen gas coming in contact with the atmosphere. This is totally normal, as the Electron is fueled with highly refined kerosene and cryogenic liquid oxygen. As Electron warms up, it's standard to lose some of our liquid oxygen. Throughout preparation, we continue to top it off so we have the correct levels for flight.
Copy. All stations on mission cord. Range is green. Auto sequence armed.
Copy that, RCO. Avionics is flight on mission.
Flight avionics.
Please confirm TVC battery charging is disabled.
A quick check-in on the countdown. We're 3 minutes and 30 seconds until our target liftoff for today's mission. Things are starting to ramp up, so I'm going to leave you with the team in mission control for the remainder of the count, and I'll check back in with you shortly after liftoff.
And all stations, flight on mission cord. From now on, there should be no red flags in your LCCs. LD, flight on mission.
Yep, this LD.
The vehicle is green, ready for flight.
Copy. VMS, this is LD on mission code.
Go ahead.
Please confirm flight computer ASGOs are green.
We're currently just flicking on the lower bound of the stage 1 locks mess.
Please lock the auto sequence and confirm.
Auto sequence is locked.
All operators, we are go for auto sequence start at T-minus nuts.
Avionics, flight on mission.
Flight avionics.
Please confirm all AV bats have been switched to internal power.
Vehicles on internal power.
RCO flight.
Go ahead.
Avionics, please confirm stage power disabled on all 3 stages.
Stage power is disabled on all 3 stages.
All stations be advised, vehicles now on internal power. PLS flight on mission. PLS copy. Please begin lock skid recirculation. Copy. PLS flight on mission.
PLS copies.
Please disable anti-geysering and confirm.
All disabled.
Stage 1 flight mission.
Light stage 1.
Please confirm stage 1 is pressed. LOX 400, Kira 225.
Confirm press.
And stage 2, please confirm stage 2 is pressed. LOX 365, Kira 205.
Stage 2 is pressed.
High flow engine purge running. And deluge running.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Left off detected.
Beginning bit traffic.
And we're off the pad for our 8th Electron launch. Soon we'll be approaching the point of the flight where the forces against the rocket are at their peak, otherwise known as max Q, or maximum aerodynamic pressure, Let's listen in for that call.
HP battery discharge nominal.
Vehicle is supersonic. Approaching maximum dynamic pressure. Pass through max Q.
Brutus has entered flight mode.
There you have it. Electron has gone supersonic and has made its way through max Q. We'll now tick through a number of milestones on the way to orbit.
Guidance is nominal, 50 seconds remaining.
AOS Chatham Station.
Stage 1 propulsion remains nominal. Stand by for MECO in approximately 30 seconds.
Soon the 9 Rutherford engines on Electron's first stage will shut off ahead of its separation from the rest of the rocket. Once Stage 1 and Stage 2 have separated, the final vacuum-optimized Rutherford engine on Electron's second stage will come to life and propel Electron the rest of the way to orbit.
Stage 1 MECO confirmed.
Stage separation successful.
Stage 2 ignition. Propulsion is nominal.
And there it is. Main engine cutoff has been confirmed, and Electron's first and second stages have successfully separated. For the payloads to be deployed from the kick stage, first the protective fairing needs to open up and fall away. Things are looking good, and propulsion is nominal as we approach fairing separation.
Fairing jettison succeeded.
The fairing is separated, clearing the way for payload deployment coming up in approximately 50 minutes from now.
Guidance is nominal, altitude is 150 kilometers.
Mission Control, I can check in with you at 3 minutes and 45 seconds into flight. Everything is looking great as Electron continues onto orbit.
Stage 2 HVB battery discharge is nominal.
If you're just joining us for the webcast of Electron's Lookma No Hands mission, we've had
nominal.
successful main engine cutoff, stage separation, and stage 2 ignition. Electron is looking healthy with a velocity of 10,000 kilometers per hour and an altitude of 220 kilometers.
Guidance is nominal.
Quick update from Rocket Lab Mission Control. Electron's propulsion is nominal ahead of our battery hot swap.
200 seconds remaining.
So we're now at T
Vehicles
plus
to the
5
stage.
minutes and 45 seconds since liftoff, and next on the list of mission milestones is the battery hot swap. Electron's batteries power electric pumps on the Rutherford engines, but once we get to this point in the mission, these batteries are depleted and we no longer need them. So we do a quick hot swap from the depleted batteries over to another fully charged one to maintain power to the engine and provide a much more efficient ride the rest of the way to orbit. Let's listen in for the call on the hot swap.
Throttling down.
Hot swap successful.
Battery jettison confirmed.
Stage 2 propulsion still nominal.
As you've just heard, we've had successful battery hot swap. Electron's trajectory continues to look nominal. So we're approximately a minute and 45 seconds away from kick stage separation. Velocity is 18,000 kilometers per hour and altitude is 304 kilometers. The Look Ma No Hands mission continues to look good.
HV battery discharge holding nominal.
1 minute remaining. Speed is 6 kilometers per second. Altitude is 310 kilometers.
Just a quick update for you here on Rocket Lab's Look Ma No Hands mission. We're about 1 minute away from kick stage separation and Electron continues nominally.
Entering burnout detect mode.
Twenty seconds remaining. Guidance is in terminal. Five seconds.
Engine shut down.
Good transfer orbit achieved.
As you just saw, Electron's second stage is shut down as planned. With the clean separation of the kick stage, Electron is orbital, and it feels good to be back. So here's a quick explanation of how this innovative Electron kick stage works to deploy payloads to orbit. We use stage 2 to take the payload to an elliptical parking orbit, as shown here, before the kick stage separates from Electron's second stage. By leaving the second stage in this highly elliptical orbit, it experiences a high amount of atmospheric drag, and as a result, the stage is dragged back into the Earth's atmosphere to be burned up in just a matter of weeks. Meanwhile, the kick stage lights its 3D printed Curie engine and circularizes this orbit before deploying the payload. The kick stage is equipped with a cold gas reaction control system, which means we can accurately point the kick stage and deploy payloads to incredibly precise orbits, even when we're launching multiple satellites at once. Once the kick stage has deployed the payload, the Curie engine is capable of reigniting and performing a deorbit maneuver to burn itself up, leaving nothing behind in orbit but our customer satellites. So with that, I want to thank our mission partners for choosing to launch on our Electron, and thank you for joining us for our 8th Electron launch. We look forward to seeing you back here next month for another mission. I'm Max Muncy, and depending on where you are in the world, have yourself a good morning, a good day, or a good night. This is Rocket Lab Mission Control, signing off.